I begin. All right, good. Welcome, class. Here's where we are right now. We have 27 minutes. We're going to make this video, and hopefully we're going to finish it before the bell rings. We need to talk about our friend, this function, f of x equals e to the x. On a scale of 1 to 10, what is your deep understanding and comfort level with this function? Low. Good. That's what I thought. For whatever reason, I think you're just not ready for this in pre-calc A and B. And so what I have traditionally done in pre-calc C is take an entire half an hour one day and re-explain what this function is. I do that every single year except this year because of baby things. So I'm going to do that now, but in an abbreviated fashion. Can I go really, really fast? Yeah, hopefully. Okay, it's like you have this thing called interest. And what is, I'm going to take it all the way back. What is interest? You have a certain amount of money. Like suppose you have $100. And you know that in 1 year from now, you would like to buy a shiny new bicycle that costs $100. So you could just keep your $100 in your mattress, and then a year later, it would still be there. That's one option. Another option is you could put your money in a bank. And that sounds better because then you don't have to worry about someone stealing your money. And also, while the bank holds on to your money, they play with it. Basically, they gamble with it. And they gamble on things that are mostly working out overall. And therefore, the bank makes money with your money. So the bank is going to pay you for the right to hold on to your money safely for you for a whole year. Everyone with me? This is called interest. And the bank says, in a kind of a way, I will pay you 6% interest. And our interest rate is always phrased as a percentage. And what the bank is explicitly, but also implicitly promising you when they offer a 6% annual interest rate is, yo, you give me some money, if you wait an entire year, then at the end of that year, I will give you $6 extra. Sound good? So the 6% says that if you keep your money in my bank for 1 year, at the end of the year, I will give you back 6% of the amount of money that you gave me. Okay, that's the most simple, basic possible concept. Now, based on this idea, I wonder what would happen. This assumes we have no background knowledge whatsoever. I wonder what would happen if we only kept our money in for half a year. So if you went to this bank with an annual interest of 6% and you gave them your $100, but then suddenly in the middle of the year, a different new shiny bike became available and you're like, I need this bike now. And you want your money back halfway through the year. Now, in some terrible situation that would be really sad, you could imagine, it's theoretically possible for that bank to say, no, you can't have your money back. You said I could have it for a whole year. That's one option. Or the other option the bank might say is, I'll give you your money back, but I'm only giving you your $100 back. I'm not giving you your $6 until you keep the money in there for an entire year. Both of those are theoretically possible, but both of those are annoying. Because people generally want their money. And even though they give the money to the bank, they think of the money as still theirs, the bank is just holding it and they can have it on demand. Therefore, for all of these reasons, it has become standard, this is not a property of math, this is a property of life, to be able to get your money back whenever you want it. And the amount of money that you are entitled to in interest is a product of how long your money was in the bank. And so, the interest earned, in this case, I think quite reasonably, would be what? $3. That's right. So now, because you've only kept your money in the bank for half of the year, you only get $3. Okay, this leads to the following formula for interest. The interest that you get is a product of the principal, the amount of money you invested, times the interest rate. That's what we've seen so far, but also times the amount of time you leave the money in the bank. So if you leave the money in the bank for the full year, as was sort of built into the promise of 6% annual interest, then T is 1. and so you get the full $6, but if T is only half a year, then you only get half as much. Who's with me? Okay, good. This is called the principal. This is in dollars. This is the interest rate, and it's important that it's an annual interest rate. So and T is the time in years. Okay, and sometimes you don't care so much about the interest, but instead you care about the amount of money you have left, or the amount of money you have in the bank at a given time, were you to withdraw it all. So if the amount of money you have in the bank at any given moment, you could say, if you withdrew it all, is kind of like how much you put in there plus how much interest you earned. So, right? And maybe to put that a little bit differently, at any given moment, you could go to the bank and say, give me all my money. What do you get? You get the original amount of money you gave them plus the earned interest. Follow? Okay, but then the earned interest we've just agreed is the principal times the interest rate times the amount of time. And so this gives rise to this formula, which is P times 1 plus RT. Okay, so this is called simple interest.
You factored out the P?
I did. So simple interest is this way of computing interest. The problem with simple interest, and I'm not sure whether or not Kirk explained this to you like this or not, is that the system can be kind of gamed a little bit. Because if you have $100 and you find a bank which is offering 6% interest, and you know that you need to put the money in the bank for 1 year, and in 1 year, you're gonna get your driver's license, and then you're gonna go buy a car. Then your first option is to just do what I've been saying so far, which is you put the $100 in, you come back 1 year later, and how much money do you get when you walk in? You walk in January 1st, you walk in, you give them $100, then January 1st, exactly 1 year later, you come back and you say, give me my money, and they give you back $106. Okay, so that's option 1. But unfortunately, fortunately, however you want to think about it, there's another option, option 2. In option 2, you try to trick the bank into getting more money. So here's what happens. You invest $100 at 6% interest, but then you only leave the money in the bank for half a year. And then on July 1st, exactly halfway through the year, you walk into the bank and you say, hello, I'm that guy. Please, I would like to close my account now. Give me all of my money. And then what do you walk out with? $103. Then you go to the parking lot. You open up your glove compartment of your car, and where you have all kinds of wigs and fake glasses and clown noses and weird things like that. And then very discreetly you walk back into the bank and you say, hello, bank person, I am a new person that you have never seen before. I would like to open a new account. I have $103 that I would like to deposit, and can I open a new account please at 6% interest? And then you leave. You guys following the story? And then you come back exactly half a year later, in other words on January 1st, the time that you were planning to make anyway. Now how much money do you have? Oh, you have the $103, plus you have the amount of money that you earned in interest during that second half of the year. But how much money did you earn on interest in the second half of the year?
6% of 103.
6% of 103, exactly.
If somebody can do that in their head, I'm impressed.
Yeah, I think it's actually not so hard because it's like something. It's like 9 cents, right? Yeah, this is $3.09. All right, and thus we end the year with $106.09. Okay, how did we magically create 9 more cents in value, even though I started with the same amount of money and I kept the money in the bank the same amount of time? The difference is that in option 1, you are earning 6% interest for the entire year on, so to speak, the principal of $100. Whereas in the second scenario, during the first half of the year, you were earning your interest on the 100, but during the second half of the year, you were earning the interest on 103.
Yeah, but you
Who's-
can't even buy gum.
Who's with me? This is all review of pre-calc B so far.
Yeah.
Okay, so wait, pause a second. So, in other words, it always benefits you to withdraw all your money and to then reinvest that money and to call that your principal. Agree? Okay, this is a silly system because this encourages people to just like randomly like walk into banks, closing their accounts, withdrawing all their money, putting on fake mustaches and wigs, and redepositing the money back in the account again. That's just ridiculous. Does everyone agree that's ridiculous? Okay, and so we have solved this problem with math, and we've solved this problem with the concept of compound interest. Healy, you're going to say something?
Did banks ever actually use the system?
I'll just say probably yes. I don't know, some bank from like 300 years ago that didn't know how to do math. Sure. You can find any crazy thing that you think is like terrible or even illegal. You could probably find some loan sharky, crazy type, you know, whatever, developing economy or illegal economy that's doing it that way. Sure. One of my girlfriends was in, a long time ago, was doing getting a master's degree in econ, and her thesis, she like went to India and just like went traveling all around India for like 3 months, researching like the Indian banking industry, and just found the most crazy, shady, evil, terrible, exploitative Indian banks in the really, especially in the big poor cities. Good. Compound interest. What is compound interest? Compound interest is the way for the bank to simulate the process of withdrawing all the money and redepositing it. And so now we have sort of 4 now key points. P is the principal in dollars. R is the interest rate. T is the total amount of time your money is in the bank, but now this new thing, N, this is the number of times per year that the bank compounds. Okay, and compounds means just that it withdraws the money sort of for you, so to speak, and redeposits it. It's turning whatever amount of money you've earned so far into the principal for the subsequent cycle. Who's with me? This is still all review. Okay, let's develop right now on the spot the compound interest formula. Okay, so you should be thinking that let's just in our minds think of n as like 12. If n is 12, that means that 12 times per year, so every month, your bank withdraws all your money and puts it back in again and calls that new thing the principal. Okay, so what we can do is we can make a big chart. I guess let's do it over here. Suppose I have a certain amount of suppose this is a certain time, and this is the amount of money I have at that time. And, okay, let's begin. So let's talk about at time 0. Well, at time 0, the amount of money I have is just P, the principal. Agreed? Okay. So now, let's consider the next time about which I can ask the question, how much money do I have? Well, if the bank compounds 12 times a year, or n times a year, then the next time to check in on this interesting money situation would be after 1 month, right? Okay, so essentially after 1/12 of a year. All right, so I'm going to call that 1/n of a year because I want to do this in general. So where 1/n of the year has gone by, where if n is 12, we're talking about 1 month, then we check back in on the amount of money. Well, how much money do I have at this point? I have my original principal, plus I have the amount of interest that I earned during that 1 month. How much interest did I earn during that 1/n of a year? Well, I've earned my principal times my interest rate times the amount of time that elapsed, which is 1 over n. And thus, the amount of money I have in the bank is P times 1 plus R over n. Okay. And then the key thing to realize that in this new system of compound interest, the bank now compounds this amount of money. So after 1/n of a year has gone by, the bank takes this number and makes it the principal for the subsequent month. Who's with me? It's all review. Okay, so let's check in 1 month later, where 2/nths of a year have gone by, or 2 months have gone by. Well now, how much money do I have in the bank? Well, I have this amount of money. That was the amount of money in the bank at the beginning of the month. So P times 1 plus R over N. Okay. Plus, how much interest did I earn during month 2? I think this is kind of hard.
P times 1 plus R over N.
So that number, right?
Times R.
That is the amount of money sitting in the bank at the beginning of the month. So I earned interest on that number times the interest rate times the amount of time that elapsed, which is 1 over N. Who is with me? Do you see what's going on here? Now the principal on which I earn interest was the amount of money sitting in the bank at the beginning of that time interval. Okay, and this is by factoring out a P times 1 plus R over N is, I'm left with 1 plus R over N. In other words, it's P times 1 plus R over N squared. Cool? Okay, might have gone out of frame. John Nichols is going to fix that. Okay, let's do one more. You can also just pick up the entire camera and move it over there to Junior. It's kind of crappy videoing, but maybe it's the best. What about after 3 nths of a month have gone by? Fast, 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 fast. How much money do I have in the bank at the beginning of month 3? P times 1 plus R over N squared, right? So yes.
Yes.
Okay, and now so I have that amount of money, plus I have the interest that I earned during month 3. How much interest did I earn during month 3? That number
Times R.
times the amount, times the interest rate, times the time elapsed, which is 1 over N, and that's how I get, if I factor out P times 1 plus R over N squared, then I'm left with 1 plus R over N, so that's P times 1 plus R over N cubed. Okay, what is this? How would you describe this thing that we now have? Yeah, this table.
I was just going to say that there's now like an exponent that we have to factor into the.
Okay, good. Wait, what kind of object is this? All right, it is a geometric sequence. Good job, class. This is a geometric sequence. It's a sequence which is going up each time by a factor of 1 plus R over N. That's why it's highly relevant to do this in Pre-Calc C sometime in like mid-November, but we just didn't have a chance to squeeze it in. Skipping forward to when 1 year has gone by, N over N. Now, how much am I going to have? If you're following the pattern, what's going to be, the only really question is, this number is going up by 1 every nth of a year. So after 1 year has gone by, that's n nths of a year. So 12, if you're thinking of n as 12, then it would be 12 times I've done this compounding. But if you're thinking of n as n, then n times I've done this compounding, yeah. And so what I'm going to have is P times 1 plus R over N to the nth. Because after n nths of a year have gone by, I have performed this compounding operation n times. Follow? Okay, and then the final step is to skip ahead to imagine now that like sort of t years have happened. Okay, so now if t years have gone by and the money was just left in the bank like that, then the only thing I need to know really to answer this question is what? How many compoundings have happened? Well, if t years have gone by and I compound n times per year, then how many times have I done the compounding? nt. Ta-da! So this is what people call the compound interest formula. The compound interest formula, I just did this at probably half the speed that Kirk did it. Maybe not. Maybe is this pretty much what Kirk did?
Yeah.
This exact thing? Okay, so I have just reproven to you that this is the formula for compound interest. Okay, why are we talking about this right now? You might ask. Can I get that eraser? Talking about this right now because, the good one?
Oh, is that me? Sorry.
Sorry. Talking about this right now because something very interesting
No hands.
happens if we, good. If we invest $1 at 1% interest, no, at 100%, whoa, $1 at 100% interest for 1 year. And we investigate what happens to n. Okay, let's go. Well, according to our understanding of this, so what I'm going to do is I'm going to consider the different. This is also still pre-calc review. I'm going to consider the different number of times compounding per year and how much I'm going to end up with. All right, if I only compound once per year, then that's like not compounding at all because I'm only keeping the money in the bank for 1 year. So how much money am I going to have at the end of the year? $2, right? Because 100% interest is going to give you 100% of what you deposit. So you deposited $1, at the end of the year you're going to have earned $1. Okay, and if you want to use the formula, it's like 1 times 1 plus R is 1 over n is 1 to the 1, right? Because t is just 1 and n is just 1. Okay, what if I compound twice per year? Well, if I compound twice per year, then halfway through the year, well, okay, let's just do it. So I now have my principal is still 1 plus R is still 1, but now I've compounded twice a year and to the 2. And what is this? You can do it in your head. This is 225, 9/4. This is 225. So that is some pretty dramatic difference. This is why compound interest is so great. If I invest my $1 at 100% interest in a bank that doesn't do any compounding, I only earn $1. But if they compound twice a year, I earn $2.25. All right, now someone get out a calculator, or even better, Samantha, can you log on to that computer and also turn the green board on? What if I go? You got to get closer to it, I think maybe. What if I compound 4 times per year? Well, then that is 1 times 1 plus 1/4 to the 4. Okay, that I can't do in my head, but it turns out to be something like, I don't remember, 261. Is someone doing it? All right, no one's doing it. All right, good. If I compound 12 times per year, what am I going to get? Oh, is Stein on there or something? Oh, I'm on here. Great.
Wait, sir, do you want me to fill it out?
Yeah, Peter, you should do it.
What is this? 1 plus 1/4 to the 4th? Is it 261? No one did it? 30 people in this class?
Yeah.
All right. Then this is 1 plus 1/12 to the 12. And you might be starting to think, man, these numbers are just getting bigger and bigger. Wait, no, go on, do it. Type in, please. Yeah, good.
It's 2.44 and then 2.61.
2.44. Money. Next one. 2.61. Man, these numbers are going up and up and up and up. But if I compound like 1,000,000 times per year, which you would think maybe I'm going to get so much money. In fact, what do I get? Can someone type?
Not that
Doesn't
much.
want to?
It's gonna peak. It's gonna like peak and like go like that, right?
Yeah. What is the answer?
Just type in just one time.
Wait, Samantha. You know what I want? Just type in these numbers so we can all see. Very good.
Sure.
Yo.
Doesn't it?
Yeah. What do we hit?
2.72.
2.72. What is 2.72? It is E. This is literally what the number E is. This is what you learned in pre-calc B, but perhaps forgot. E is, or your first exposure to E at least, E is what happens when you take the expression 1 plus 1 over n to the n and let n go to infinity. This is one way of doing it, sure. Yeah, and he's graphing 1 plus 1 over n to the n. And if you zoom out, you see that at first you get some rapid increases, but then they level off. And in fact, this function has like a limit. The limit is e. And if you think of this as a sequence, then the definition of e, now I'm using some calculus vocabulary that Kirk didn't use, that e is in fact defined to be the limit as n approaches infinity of 1 plus 1 over n to the n. Okay. This is and if you think about this, this should sort of somehow kind of make sense to you, because if on the one hand, suppose you take 1.01, in other words, a tiny number, a number that's very, very close to 1, and you raise it to the nth power, what happens as n goes to infinity?
It gets bigger and bigger.
What happens if you keep multiplying by 1.01 up to like a billion?
It gets bigger.
Can you say more precisely than bigger?
It increases.
Yeah, this goes to infinity, right? As n goes to infinity, does everyone agree?
Yeah.
If you raise 1.01, it's an exponential function, it's getting bigger and bigger. Okay, so a number just a tiny bit more than 1, as you raise n to infinity, is going to go to infinity. But, on the other hand, if you give me a number, if you raise 1 plus 1 over n to like a really, really big number, like even like a whatever, 100,000, what happens as n goes to infinity?
It's simple, goes to 1, right?
This goes to 1 now, right? Because if even though you're multiplying, even though you're raising this number to the millionth power or whatever it is, even though n is getting really, really big, then as n gets really, really big, this number gets really, really close. So this is going to 1. So do you feel the tension? The inside is sort of drawing you down to 1. The exponent is drawing you up to infinity. What you in fact get is this number e. Okay. We didn't even get through 40% of what I wanted to do this half hour. There's another way of defining e using a limit switchy. Let a be 1 over n. If a is 1 over n, then as n goes to infinity, what happens to a?
It goes to 0.
It goes to 0 plus, specifically. Okay, so I may alternatively define e as the limit as a goes to 0 plus of
1 plus a.
to the 1 over a. Alright, so these are two different, that was all pre-calc review, and these are two different ways of defining this important number e. Okay, next class, or possibly got a video I record this afternoon, we are going to differentiate this function. Goodbye, class.